Okay, this is chapter 14, which is environmental health and toxicology. The case study that they talk about is BPA, and it's located in a lot of products, and what happens is it leaches into our bodies, and BPA actually mimics estrogen at low doses. It's currently banned in California in all children's products. It became really popular with in baby bottles, that they realized that the BPA was contaminating and poisoning the children and babies. So it's supposed to be all BPA free for baby bottles. However, it's not banned completely in the States and other food products. So California is the most progressive of all the states, so they've completely banned it in all children's products, and BPA is banned in all food containers in Europe. So they're a little ahead of us. All right. Next page. Big thing to know about is infectious disease, and that means it's communicable or transmissible. And there's two things: vectors, which is what uses to pass a disease, so this could be like your mosquito, and then the pathogen, and this is basically what the disease is. So it's either a bacteria or protozoa. So if you remember in our toxins charts, we identified what the vector is, the means of passing on the disease, as well as the pathogen. So make sure that you know what those are. One thing we could talk about is mad cow disease. And traditionally in beef products, if you cook it, all the bacteria or the pathogens are killed. However, the way that mad cow disease works, it's actually in the protein itself. So even if you fully cook it, it doesn't die or it's not cooled off. So this is why this was so scary. It's not like all the other bacteria. So next thing you have to make sure you know about is these charts on page 358. And big thing you need to make sure you know, the #1 cause of death in the world and developed countries is currently cardiovascular disease or heart disease. As you can see here, 31.1%. However, over time, cancer is going to eventually become #1. So just be aware of that. Now, in developing countries, though, it's infectious diseases are the #1 killers. Okay. If you look here, they give you examples of the different infectious diseases. Diarrheal diseases, that includes chloria or giardia. And the reason why infectious diseases are the #1 killers in developing countries is the lack of vaccines. So again, lack of education, medical advancement, hence why they are dying from different diseases than the developed world. Now, why is infectious diseases continuing to spread? One big reason is global air travel. Prior to global air travel, diseases didn't have the means of going from one place to another quickly. Ebola virus, for example, that never would have been able to be spread from Africa to the United States if it wasn't for air travel. Usually if you had to travel to the United States, it was via boat, which would take a much longer time. Thus, it wouldn't be able to spread fast enough. The people would have died on the boat before they reached the United States, and they would never been allowed to enter. However, with air travel, it's only of so many hours, and they're here instead of weeks or days. Another example is bioterrorism. After September 11th, there was an anthrax scare where people thought they were getting anthrax in their mail. It's this white powdery substance. So this was actually really big when I was a freshman in college, as potential of bioterrorism. Another spread is global warming. So many of the diseases that we've talked about thrive in warmer climates. So as the world gets warmer, that allows these infectious diseases to spread even easier. Or it's because of their vector survives in these warmer climates. So if you think about malaria, it's spread by mosquitoes. So if there's no cold season where the mosquitoes die off or go dormant, then that means that the mosquitoes can carry and pass on the disease throughout the year instead of just in one season. All right, next page. Vocab to know. Make sure you know the difference between toxicology, toxicity, toxicant. Radon. Now, all of you, if you have a house or live in a basement area, you need to have a radon detector. And radon is a natural gas that's from bedrock. It basically is produced as the natural bedrock and ground decomposes and breaks down. So you only really worry about radon is in basement areas or places that have basements. If you don't, then you don't have to worry about it. Lead poisoning, we've talked a lot about this. Make sure you know about it and side effects. BPDE, this is that flame retardant that we found out that they put in our mattresses and our pillows. Not really necessary, it's bad, and we all have this in our systems. Make sure you know what a toxin is. Okay, asbestos, this is a popular one. It was an insulator that we used to use in the past. It was also fire resistant. And the problem with asbestos is when it breaks down, it actually causes two diseases: mesothelioma, which is a lung cancer that's specifically caused by asbestos, and then we also have asbestosis. And just remember, toxins can be either natural or synthetic, so they can be both, so man-made or naturally occurring. Okay. Next, what we're going to be talking about is make sure that you look at this figure here. It's talking about how our streams and our aquifers and how they're impacted depending on if they're agriculture, urban, or undeveloped areas. Big thing you have to make sure you realize is that obviously agriculture areas are going to be the most greatly impacted. The stream water and groundwater due to pesticides use, fertilizers, and things like that. So they're mostly most contaminated agriculture areas. Then it's urban areas, and then lastly, undeveloped areas. Okay, so make sure you know that information. Know that chemicals are in all of our bodies. Okay, we all have some sort of chemicals that are permanently in our bodies. Also, make sure you know who Rachel Carson is. She's the one who wrote the book Silent Spring, and it was all about the effects of DDT, and her book actually led to the banning of DDT in the USA. All right, so she may or may not pop up from the 1960s when she wrote her book, so make sure you remember about her. Okay, other vocabulary you should know. Carcinogens, mutagens, make sure you know what that means. Neurotoxins, a perfect example is lead. Minamata Bay in Japan, we talked about how they dumped mercury into the bay and it got into all the fish, and then all the people and the animals that ate from the bay ended up getting Minamata's disease. And this is a neurological disease where they almost had like seizures and it looked like they were epilepsy. Sad story that happened. Okay, make sure you know what allergens are and pathway inhibitors. Also remember that tetragens, which I didn't include here, but those are ones that affect the unborn child. Okay, those that are in the womb of their mother. Okay. All right, one big thing that we need to talk about is endocrine disruptors. All right, and there's an image that goes with it. And the difference with endocrine disruptors is there are the opposite effects as all your other toxins. All right. Usually with all their toxins, the higher the doses causes the immune system to kick in. So basically, when you have a high dose of an endocrine disruptor, your immune system kicks in, and then it actually prevents it from bothering you. It's the low levels that cause problems of your endocrine disruptors. All right, so let's look at this curve here. So it's your dose and your deaths or problems. So at a little dose, we actually have more deaths or problems that occur than at a higher dose. Okay, and these deaths or problems could include fertility, infertility problems, or cancer. And the reason why is these small little levels, your body doesn't detect them, so their defense mechanisms don't pop in, and that's why these problems can occur. Now, for regular toxins, the dosage makes the poison, okay? So as you can see here, the higher the dosage, the more deaths or problems occur. Opposite for your endocrine disruptors. So if you look at your diagram here, your hormone binding, you have your hormone, you have your receptors. Ideally, they want to find a match, okay, in your cells. That's how that works. However, your endocrine disruptors mimic hormones. So here's your regular hormone, here's your mimic. And what happens is they connect with the receptors. and they basically almost are identical. The response is identical that's caused by the hormone. So BPA, which we talked about before, basically is an endocrine disruptor, and it comes in and mimics the hormones, and it causes the body to react. This is why we've had such an increase in infertility, testicular cancer, and why boys and girls are reaching puberty faster. And this is all due to all these endocrine disruptors that are mimicking hormones. So it's making your body think you're reaching puberty faster than you really are. Now, why is this still going on? Why haven't we stopped it? The problem is industry only focuses on high dosages. So based off of the study and what we talked about, at high dosages, we don't have many deaths and we don't have a lot of problems. So the industry says like, oh, it's no problem. The problem is the law needs to change, okay? We need to focus on the small dosage as well for endocrine disruptors, but unfortunately the laws have not caught up with the science. All right, the photo's down here. It talks about phthalates. Now, again, this is something that's been banned in Europe, and you might notice that a lot of the green beauty products or green products say that they're phthalate-free, sulfate-free. These are in a lot of your shampoos, your nail polishes, things like that. So if you want to worry about that, these hormone disrupting phthalates, you can actually search for products. They all will say on their labels if they're phthalate-free, your makeups and things. So it's something to consider when you're buying your products. Okay, make sure that you know the difference between acute and chronic exposures. Remember that acute or low exposure over long periods of time is your chronic exposure, and then acute is high exposure over short periods of time. Also synergistic effects. This is when two chemicals that are safe individually or by themselves get mixed together and then cause a problem. So just to give you that idea. All right, the next thing we're going to talk about is global distillation. And here you have this lovely diagram. And basically what happens is all of our ocean currents and our atmospheric currents make a lot of these long-lasting chemicals and pollutants and toxins collect at the North Pole, okay? And so we have huge amounts of banned chemicals here. This is where there's a huge amounts of DDT and PCBs that are basically stuck on our planet and can't break down. So they collect and gather here. So what happens is it's now polluting and like kind of overtaking those natural food webs, and it's accumulating in all the biota. So just make sure that you understand that all the pollutants eventually end up in this location. All right, something your book doesn't talk about that we should know is POP, which is persistent organic pollutants. And these are basically the ones that go through global distillation. Basically, they don't break down. They resist degradation. They are not soluble in water. So again, they don't disappear in water, and they can withstand long-range transport, meaning they can survive forever. So perfect examples of these are your DDT and your PCBs. Okay. This is just a chart on synthetic chemicals and how they travel through the environment and impact humans and other organisms. Okay. Big thing to make sure you know, fish and frogs are actually indicator species for pollution. They're very sensitive, so just make sure that you review that part. All right, so we use them as indicator species of certain contaminants or pollutants. Okay. Make sure you know the difference between bioaccumulation and biomagnification. We read a case study about this with tuna. Bioaccumulation is when a chemical or a toxin accumulates in the tissues, usually your fatty tissues. And biomagnification is as an organism is eaten that contains a contaminant in their tissues, as you travel up the food chain, it gets higher and higher and higher concentrations. So as you can look at this lovely food chain here. All right. Now, some broken down toxins are also toxic. So DDT to DDE, they're both toxic. And DDT, why it was banned in the first place is because it was made eggs weak, the shells, in all these different organisms.